Okay. Hello, everyone. Let me fix up this mic setting. Okay, that looks better. Welcome to the 15111911 makeup lecture video because of the King's public holiday coming up on Monday. So I'm recording this after the first two lectures to continue on so we don't get stuck and you can get going with the with the assignments when they're ready to release and the labs, so you're not held up. So that's what we're doing today. I've also improved, I hope, my lecture streaming setup for the at-home lectures, so it should be a little bit better. Okay. Let's get started with the content, and we're going to get started with a recap of, let me put this over here, of the lecture content from, well, for me this week, for you maybe last week. So this is week 2, lecture 1, control flow. Help sessions will be starting maybe not early, but soon. So just make sure you're keeping an eye on your emails for announcements and the course page for that important information, and the forum. All the announcements get logged onto the forum. And we had 103 responses to the feedback form from the Tuesday lecture. The overview is that we liked the format, the quality, especially the in-person lectures, but also the online lecture. And most people seem to like the pace. Maybe some people have asked for it to slow down a little bit for the demos in particular. So bear with me, I'm still getting used to the online lecture format a little bit. Okay. So week 1 is a big week. You went to your first tute lab, hopefully. You wrote your first program, hello-world.c. We looked at memory and variables, reading and writing to the terminal, and some basic arithmetic, really basic. Week 1 has a lot of stuff to get through, and we're not really slowing down. This week we're going to talk about control flow, a really important topic, logical operators, we'll talk more about what those are, and repetition. So we start unlocking more tools that we can use in our programs that let us do more interesting things. But let's get started with a recap on input and output. So this is the week 1 content. So printf, really important function. It's part of the standard input-output library, stdio.h. So what that means is to use it, you need to include standard input.h as one of the early lines of the program. And it's responsible for outputting text to the terminal or printing text to the terminal with a format string. So here's a little demo program. Don't mind that it's wrapping on 2 lines, but have a moment to think about what this will print out to the terminal. Okay, this is using a variable as a stand-in. So we have an integer variable called course code. It's assigned the integer 1511 because that's the course code of the course. And then we have this printf with the string. We always have a single format string passed to printf. And it's welcome to comp, and then there's a few weird characters here. So what's going on here? And remember, again, we covered this in lecture 2 from week 1, but the first thing we have here is the %d, that is the placeholder for a decimal integer, which means anything passed afterwards, in this case, the course code integer, gets substituted into %d. So it's going to print COMP1511. It's going to turn those integers into characters. The \n is the new line character, and so that means that a new line will get printed at the end of the string. So that'll be welcome to COMP1511. And here's that output right there. So new lines, this is what we were just talking about. Here's a good little example. Hello world without a new line gets you hello world, and then the prompt gets printed straight after. Do you see that? Whereas when we pass a new line to hello world, we get hello world new line and then the prompt. So it's just a new line character. You could do double \n and you'd get 2 new line characters. Okay, that's printing. Scanning, it's the opposite direction. So it's getting data from the terminal. The user can type in some text and it will read it. And usually what we do, or we pretty much always do, is store that in a variable. Same thing as printf, we need to include standard io.h. So here's a really small example for scanning in an age, an integer. So we have to have a variable set up that can store an integer, and we're calling it age. We prompt the user for what we want them to enter. In this case, we're just saying enter your age. And then we have scanf, okay? Again, like printing, we have the input string, the format string. And so what we're saying is, what should I be asking the user for? In this case, a single integer, a decimal integer. So we use that %d flag again. We scan it into, we need this ampersand with scanf, and we're scanning into the variable age. So whatever, ideally, whole number that the user types in at the terminal will get stored in the age variable and we can retrieve it later. All right, so that's the recap, and let's get on to this week's content, control flow. So what is control flow? Every program we've written so far, and we haven't written many together, but it's the numbers growing, does the exact same thing every time the program runs, right? So you could run your program over and over and over. Maybe you enter some different data into the terminal, but what happens to that data, where it gets stored, what it does with it, it's all exactly the same. But sometimes we need to do different things depending on what happens in our programs. We need to have decisions or the ability to make decisions in our programs. And this is what control flow is. We are controlling the flow of our program. It used to just run instruction 1, instruction 2, instruction 3, 4, 5. But now we can say 1, 2, 3. If something, so like a really simple example is if the user's age is less than 18, okay, maybe they're not allowed to continue running the program, right? So depending on some state, depending on some data that we have, we can do multiple things. And the mechanism to do that in the actual syntax of the C programming language is something that's almost in all programming languages, and it's called the if statement. So that's really important. This is the tool that lets us make branching conditions based off some condition. So what does the if statement need and what does it do? So it determines the result of a Boolean. If you remember back, we spoke about Booleans in week 1. A true or false question or decision. So is the user's age greater than 18? That's yes or no. Is the user's age less than 18? Yes or no. Is the user's age exactly 18? Yes or no, right? So you've always got to boil down a question into a yes or no answer, a Boolean question. If the answer to that question is true, you can do something. And if the answer is not true, you can do something else, for example. So here's another example. If the integer x, the value inside of that variable is even, do something. Otherwise, do something else. Whoops. So in order to understand what a yes or no or a Boolean question is, we have to understand Booleans. Booleans are kind of a data type in C, but they're also kind of not. In more modern languages, Booleans are a data type. In C, remember C is a really simple language. We just use integers. So a Boolean is basically an integer as far as we're concerned. When an integer is 1, it's true. When it's 0, it's false. Later versions of C do have a Boolean data type that you can use, standard bool.h, to access, but we don't actually need these, and they pretty much just map to 1 and 0. So here's the syntax for actually how we write an if statement. So we just use the keyword if, so we type if into our source code, open a bracket, a normal bracket, not a curly bracket, and we have a condition. We're going to talk more about conditions later, but this is the syntactical version of our yes or no question. Okay, something that evaluates to true/false. Then we have these curly braces. This is a block. So we've seen these before when we create the main function, we have the block. So it's like everything in that block belongs to the main function. Well, everything in this block runs only if the condition is true. So this is how we form out our if statements. If some condition is true, then you run everything in this block. If that condition is not true, we skip it. We do not run the block. Okay, so these lines might not run. It depends on the condition. I hope that's clear. All right, here's a real example of real syntax. Really, this is not a really good example of an if statement because it's always going to do the exact same thing, but this is completely valid code. If 1, so what's going on here? Remember we said that 1 is true. So if something is, if true, well, is true true? Yes, then we will run this block. So when this code runs, we will just see this printf statement get printed to the terminal. If we were using standard bool.h, right? So if 0 or if false, this printf will not run. Now, again, these aren't interesting questions because the same thing is going to happen. We're not actually controlling the flow of the program, but we're just looking at the syntax. So in this case, this print statement will not execute. Hopefully that's quite clear. All right, this is more interesting. This is a real question. I've got a variable, it's an integer, it's called x, and it's assigned the value 5, the integer value 5. Okay, now look at this if statement. This if statement's a bit different. We have a question or a logical statement. And what this is saying is this is valid C syntax to say if x, if the value of x, which we know is 5 in this case, is greater than or equal to 0, then you should run this block. That's what this if statement is saying. Now, is 5 greater than or equal to 0? The answer is yes. So this printf statement will run. So what is this sequence of characters? What are these logical operators? And what are the other logical operators that we can use? So here's an introductory list. Now, the first thing to remember is that all Boolean operators evaluate to true or false. So these are like yes or no statements, Boolean statements. So, and they're really kind of logical. So, what do you call these? A left-facing angle bracket is less than. So is the value on the left less than the value on the right? We have greater than, less than or equal to, greater than or equal to. Now this is important. Double equals is equal to. So is the value exactly the same? And not equal to exclamation equals. So we get a whole bunch of these tools that we can use to ask Boolean or numerical questions. Here's a warning for you. Double equals and equals are not the same thing. So one equals symbol is the assignment operator. So that puts the value on the right in the variable on the left. But double equals is asking a Boolean question. Are these two values, are the left and the right the same? And sometimes people get confused because obviously they're quite similar. So let's have a look at these examples. Question 1, 4 less than 2. What will this evaluate to? I'll give you a second to answer. And the answer is false. So 4 is not less than 2, right? So 4 less than 2 will return false. It's not true. 4 is greater than 2, that is true. 4 is less than or equal to 4. That's going to be true because 4 is equal to 4. Is 5 greater than or equal to 4? The answer is true. Is 3 equal to 3? The answer is true. Here's an interesting one, right? We can do, remember we said that characters are just integers. So they have an integer associated with each character. So is A not equal to B? Well, the answer is true because the A is an integer, B is an integer, but they've got different values. So is, whatever A is 50 something, not equal to 56, 55 to 56, then the answer is going to be true because they're not the same. So we can ask these Boolean questions of any sort of numerical data type in these cases, and the characters are forced into integers. All right, so let's bring up tigervnc. Look at that. Look how nicely I switched over. I listened to the feedback. I got my OBS set up better. I'm going to go to Documents. I'm going to go to COMP1511. I'm just CDing around. Remember we spoke about this in week 1, 2. I'm going to CD into week 1. No, I'm not. I'm going to make a directory called week 2 and CD into that. I'm just going to fix this up. There we go. Clear, resets my terminal, ls. I got nothing in here. So let's code. So let's touch a file called controlflow.c. This is going to open the Visual Studio Code editor and create a file called controlflow.c. In that directory, I'm going to close this warning. And the first thing I'm going to do is include my standard input-output library because I want to do some printing and scanning, probably. I'm going to create my main function. and I'm going to return 0. This is like our basic basic program structure. I hit Control S on my keyboard to save that file. Now, if ever I'm doing a code demo and it's too fast for you, don't forget, right, all these videos get broadcast to YouTube and then saved. You can go back and rewatch it, listen to it again, slow it down, pause the slide, right? You're in complete control. And one of the reasons that we push to YouTube is because it's a really nice video experience. So if something is too fast or too slow for you, you can just play back the video again once the lecture is published. All right, so here's a really basic program. Let's implement some control flow and run it. So the way I'm going to do that is do the very most basic control flow question. So I'm going to write a comment to plan out my program. So I'm going to just say, why don't I do this? Why don't we show off sort of the really simple thing of how it has to boil down. So if, and I have my normal braces there. So if statement means that I'm going to run an if statement. Normal braces means this is where the condition goes. Curly braces means this is what you should run if the condition was true. Now, obviously I don't have a condition here, so I've got to add one. I'm going to just put the number 1 here. So this is saying if true, which is true, then we should run this code. So if I just put a printf and I say my if statement ran, \n for a new line, semicolon. Okay, I'm going to do another one. I'm going to say printf my if statement didn't run, \n. So what do we expect to see here? We spoke about it in the slides. I would expect we only see this printf statement to run. My if statement ran because 1 is true, therefore the block should run. If what we're saying is correct, this block should not run because 0 is false. So I'm going to save this. I'm going to go back to my terminal. I'm going to compile this program. I'm just going to call it program. I don't get an error. That's great. Good on me. My if statement ran, new line, nothing else gets printed. So if these control flows are running. All right, let's change this a little bit to say, why don't we do this? So I'm going to say int age. Printf, enter your age. So we're going to ask the user for their age. Then we're going to do a scanf, %d. We're going to read a decimal integer into the variable age, &age, into age. So now, age has the user's age. What we can do with this now is actually ask an interesting question. So we can say, well, if age is less than 18, we can say, you are too young, get out. Let's comment this code out. So, or in fact, I can just delete it for now. So we have this single if statement. Now, what will this program do? So this is really interesting because this is the first time that we've written a program where the answer is I can't definitively tell you because it depends what the age is that the user types in. So let's make sure I've done that all okay. Clear this. I'm going to hit up arrow on my keyboard to rerun that same compiler flag. And I run program. Okay, enter your age. I'm going to say I am 25. Nothing happens. Why does nothing happen? Because the age is not less than 18. So this if statement does not run. We're kind of saying that you're not too young. But let's just run that program again. And this time I'm going to say I'm 15. You're too young. Get out. This is control flow. We're controlling how the program executes based upon the structure and the variables and the values of those variables. All right, let's keep going. We have a new statement. So sometimes we want to do something when that if statement is false. So, if the user's less than 18, you want to do something like you're too young. But if not, do something else, right? We're adding a second branch. So if is true, if false. So we get this thing called the else statement in C that lets us do that. Every else statement must be associated with an if statement, which totally makes sense, right? Because there's no secondary question to an else statement. So it's like, if you're greater than 18, do something else, do something else. So you must have an if statement to associate it with. And you only run the code in an else statement if the condition evaluates to false. So only one of the two will run. Let's look at the syntax. I think it actually makes it simpler to understand. We saw this before. So if some condition is true, then do these two things. If that condition is not true, so in the alternate case, do something else. So yeah, notice no condition is needed because it's just the opposite case. And else is completely optional, right? We just wrote a program that didn't use it. So sometimes you don't actually need the else statement, often you do. So here's an example. I have an integer called x and I've assigned it the value -5. And I want to do is just print out whether or not the integer is positive. So if it's positive, I want to say it's positive. If it's negative, I want to say it's negative. Well, this is exactly what an if-else statement lets us do. If x is greater than 0, so is -5 greater than 0? So the answer to that is no, false, because -5 is less than 0. So this statement won't run because it's in the true block. Then we get this else, and the else just flips the statement. And if that's true, right, then you run this you run this case. So x is negative will get printed out. All right. Another thing we can do is chain if statements. Okay. So sometimes you want like something like banding. So if the user's less than 18, you want to do something. If the user's between 18 and 21, you want to do something. And else you want to do something else if they're over 21, for example. So this chaining if statements lets you do something like this. And again, you sort of just tack on the next if statement right after the first if statements block. And each if statement gets run independently. So no matter what, the condition statement check will run. If it's true, you do something. So it's possible that, right, that like both conditions will be checked and will be true, and you'll do all three things in some cases. So hopefully that makes sense. Okay. Sometimes the questions we want to ask are more complex. So how do we check if two things are true? So what do I mean by this is how do I chain actual questions, right? So not different statements like this, but in the one expression. And so we have more Boolean operators that are really, really important. So we have first up the AND operator, which you use two ampersands next to each other to invoke. So this basically means is the Boolean operator condition, or the Boolean condition on the left and the Boolean condition on the right both true? Only then will the final evaluation be true. We have the OR operator, which, you've probably heard of these concepts from Boolean logic in mathematics. So is either side of the operator true? And the not operator just flips whatever it's associated with to the opposite. So true would become false, false would become true. So let's put this all together into a program that makes a bit of sense. I've got my age is 15 and the drinking age is 18, but I can just use 18 hard-coded in this case. So look at this. This is an example of using the AND operator to run a more complex Boolean condition. So in this case, the age is only valid if it's greater than 0. So it doesn't make sense for a 0-year-old or negative aged person to come and do something. So this will only run if age is greater than 0 and the age is less than 18. So it's a valid age, but it's not legal. And that's what this block would do. Then we can actually chain our else if. This is really important. So then we say, okay, if this whole thing is not true, right? That's the else. Let me ask a second question. Is the age greater than 18? Like, am I dealing with the age being less than 0 or am I dealing with the age being greater than 18? We have to now decide. If it's greater than 18, we'll say, okay, well, then it's a legal age. The age was greater than 18. And then else, so this is like finally, so this is like, if this is not true and this is not true, then something must have gone wrong. Age is maybe negative or something else has gone wrong. And so that's the invalid age block. right? And this is a pretty common way to structure an if, else block. And you could have more, so you could have if, else, or whatever it is might be. Sometimes these Boolean conditions can get complicated, and there's a little bit of an art to simplifying your conditions. So sometimes just changing the order of things means that you can ask less questions. All right. So let's apply this to our demo program a little bit more. We can basically recreate that same program, but I'll type it out with you. So the first thing we want to do is still scan the user's age. Now we're going to write a good program here, and we're going to take our time to do it. So one of the things I want to do is change this 18 to be like a the drinking age, the minimum drinking age. But I don't want it to be hard-coded as the value 18. So I could create a variable, but really what I want to do here is create a constant. Min age is set to 18, right? And what this lets me do is use that here so that, if I need to use that minimum age in multiple places, I don't need to keep typing 18. And if I need to change it, I just change my hash to find my constant, right? So this is a constant that sets min age to 18. Really cool. We still scan in the user's age all the same. And now we can ask some questions. I'm going to delete this. One of the ways I like to do things like this, especially if I'm checking if the age is valid, is to do something called guarding. So I try and get my bad cases or my error cases out of the way first. So I might say if the age is less than 0, right? I might say printf, that is invalid. Right? So the age can't be less than 0. And the nice thing about this is now if I get to this point, if, here, oh, whoops, we can continue our program. So then I can say else. So now let's do, we know for a fact everything here is a positive age. So that's really helpful. I know that if I'm in this block, this had to be false, which meant age is equal to or greater than 0. I might want to put equal to there because 0, I don't want to accept the age being 0 exactly. So now I know age is 1 or higher. And this helps me sort of plan out how my programs might execute. So now what do I want to do? Well, I want to ask, is that age, are they too young? And all I need to do here is ask if age is less than 18. Minimum age, remember, is 18. Now, the really cool thing, here's the part I want you to understand. This check here is within this else block. So what that means is, what this is really asking is, are you greater than 0 but less than 18? Do you see how we get both of those checks together? So that's really nice. So then we can say you are too young. I guess I could say, but valid, get out. And then I could say else. I can say printf, you are legal. Enjoy. Okay, I don't know why I'm doing so many drinking related. I guess it doesn't have to be drinking age, it can be anything. All right, so we have that little program. I come back over to here, I compile the control flow program, output it to a file called program, make sure there's no errors. I run the program, enter your age. I'm going to say 15. You're too young but valid, get out. I run the program again. What if I say I'm -1? That's invalid. Okay, that's all good. What if I say I'm 18 on the dot? You're legal, enjoy. And one more time I'm going to run it and I'm going to say I'm like 60. You're legal, enjoy. Now you might want to extend this because like if I'm like 15, 1,000 years old. It's still going to say I'm legal. That's probably invalid. So you might want to add that condition there to check what's going on. All right. I know I'm sort of powering through it. Remember, this is just a recording, so you can pause and have a break. All right, repetition, 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 repetition. The really cool thing about repetition is that it uses the same structures as control flow. In fact, because it is still control flow, you're controlling how the program is flowing, but it uses the same structures as if statements. So the syntax is really similar. It's just that what we do is different. So repetition is looping, repeating code without actually retyping it. So sometimes we just need to do things in a loop. And programmers are lazy. So if we need to do something over and over and over, we don't want to type it out over and over and over. And what if we have to do something a million times? Do I have to type a million lines of code? I mean, that doesn't make sense. So we can make computers loop for us. It's a really foundational thing that programs can do. So what are some real world examples? Walking, literally you walking around is an example of repetition, because you don't think in your head, step, 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 which is, even though that's what you're doing, what are you really doing? You're saying, well, put one foot in front of the other until, right, I'm at where I want to go. That your brain is running a repetition loop, and the action is take a step with the alternate foot. And that's exactly the same kind of things we do with programs. So we have a new statement that lets us set up repetition blocks, and it's called the while statement. It's really cool. It's really sort of powerful, but it's also kind of simple too. So the idea here is that repetitive tasks should not require repetitive code. So just like an if statement lets us do something if something is true, the while statement keeps doing something while the condition is true. And so this is what it looks like. You can sort of see here that it looks exactly like an if statement, except while is substituted for if. And there's three types of ways that we can use this syntax, this while loop. Counting loops, conditional loops, and sentinel loops. So I say while something is true, right? This is just a Boolean condition, so it's a yes or no condition. While something is true, then we just run the block. Then what happens is the block ends. Now, for an if statement, right, it would just continue running line by line. But for a while statement, something else happens. When the block ends, so this block ends here, when the block ends, we jump back and recheck the condition, the expression. And if it's still true, then we repeat ourselves. So while something is true, repeat yourself. So let's look at the three ways that we can apply that. So counting loops. So counting loops are cool. So it's basically just do something n times. So in this case, number of lines is 5, I is 0. We always need a counting variable. So this is really common when we have loops that count. And this is what we can do. So we can say while I, right, which is initialized to 0, is less than the number of lines, which is 5. So is 0 less than 5? That's a Boolean expression that's going to evaluate, in this case, to true. Therefore, we run the block. Okay? When we run the block, we just print out hey. Okay, really simple. This is really then the important part. We're adding 1 to I so that we're increasing the counter. So now I is going to be 1. Because what's happening here? I is 0 plus 1 is 1, and we assign that back to I. So I becomes 1. Now then we're asking, is 1 less than the number of lines? True. We print out hey, and I becomes 2. Is 2 less than 5? Yes. Is 3 less than 5? Yes. Is 4 less than 5? Eventually we say, is 5 less than 5? The answer is no, 5 is not less than 5. Therefore, we do not run the block, and we continue on with the program. Really powerful. Why don't we just copy this into Tiger VNC and do the demo. So I'm going to make a new file. I'm going to save it. I'm going to call counting.c. It's just saved it to my week 5 program. Oh, hello. Okay. Can I just paste here? No, I cannot paste. So there we go. Now I need, this is not quite right. I need my hash include, send.h. Whoops. I need my int main void. And I need to indent this. You can just select some code and hit tab. All right, so what do we expect here? Well, we just ran it through, so what we should see is that the word hey in a new line gets printed about 5 times. Let's go to our terminal, let's clear the terminal, let's run DCC, counting, output to a program called program. We have no error, I run the program, and look, hey, 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 hey. And the really cool thing is that I only have one printf statement, but it runs 5 times. And, you know, I can make that 500, come back here, recompile it, rerun it, and you've got to take my word for it, but there's 500 heys printed. So in one, you know, a few strokes of the keyboard, we can make a program do something like 5,000, 50,000 times. Like we get to loop. It's really cool. So that's the counting loop. Conditional loops are exactly the same idea, but a little bit different. And once again, I do not know why I picked this example, me lifting weights. I do go to the gym, but I mean, like, I'm not a gym head, but anyway. So in this case, we're not doing something n times. We're not counting up a variable. We're just doing something until something is true. So in this case, I want to loop until I've lifted around 100 kilograms of weight, you know, cumulatively. So all I'm doing here is I'm saying while the amount that I've lifted of kilograms that I've lifted is less than 100, you know, keep lifting, Jake. Right, this is a little motivational program. I add the two numbers together, like in this case, it's the weight of the dumbbells that I'm lifting. I assign that back to the lift condition, the amount, and then I check again. And so this, you know, you could imagine any sort of statement here, but the point is that you're not doing something a set number of times. Like maybe this weight changes, so it's not that you can predict how many times this program is going to loop. Like something else could change that weight, for example. And then we have the Sentinel loops, which is the hardest to get your head around. Probably, I would say, the least used. Actually, maybe that's not true. Yeah, maybe that's not true. The idea here is that we don't have a condition that we check for whether or not we're finished looping. We actually create a variable that represents a flag, and when that flag is set to false, then we're finished looping. Does that make sense? So this program actually does the exact same thing as the previous slide, except that it doesn't have the numerical condition, you know, is the amount lifted less than 100, actually described in the condition. It uses this flag, and basically we do the same you know, calculation here, but we have a special if statement that says, well, if that amount lifted does hit that 100 point, then set finish lifting to true, right? And finished lifting is an integer, but remember, integers are Booleans in C. So if a variable is set to 1, that means it's true. And we loop while we're not finished. All right, does that make sense? So while we're not finished, basically this is a really long and complicated way of saying is loop while you're not finished doing something. So this lets us offload the conditional logic to like another piece of the code or a bit more complicated logic. It's just so you don't have really long or multiple conditions here in the while statement itself. All right, let's jump back to Tiger VNC, and maybe we can do something more interesting with our program. So let's have a look. So let's drop this back down to 5. Here's a really cool thing that we can do. Okay, actually, let's say I don't want to loop a set number of times. What I want to do is loop. I'm going to have an int called finished. I'm going to set it to 0. So this is going to be like a Sentinel type of loop. This is my flag. So I want to loop while I'm not finished. Does that make sense? While we're not finished. So opposite of 0, you know, inverse of 0 is 1. So while something is 1, it will run the loop. We print hey. I'm not going to count. I don't have an I variable. I'm going to say hey, keep printing, question mark. Then what I'm going to do is in my loop, I'm going to scanf into a percent d, a percent d, and a decimal integer, into finished. So the user is actually going to type in 1 or 0. So I should say enter 1 if finished. Now, if the user scans in the integer 1, we'll come over, we'll finish the block. Remember, when a while statement ends, we come back to the condition and we flip the 1. So that'll flip to 0, and then that'll be while false, and then the program will end, and we can put a printf here to say program finishing up, \n. So this is really cool because it lets our user, actually, you know what I'm going to do? I'm going to put that all back to what it was. I'm going to make a new file. counting.c. I'm going to paste it. Thank God that copied. I'm going to save the file. I'm going to go back to my terminal. I'm going to clear this. I'm going to compile DTC. What did I call it? Counting scanning.c out into a program called program. I didn't make an error. I run the program. So it says, hey, keep printing, enter 1 if finished. So if I say 0, it's going to loop again. 0, 0, 0, 0, 0. So this is like, you know, I've got if statements, I've got control, and then if I say 1, the program's finished up. So the user's in control. This is a really powerful type of loop that you will use in many assignments and programs that you write. All right, that is control flow and repetition in 45 minutes. Now, these are powerful building blocks, but they can get even more sort of complex and powerful in the different types that they're applied in programs. So they will extend in future content, you know, labs, lectures, and things. But this is the introduction to control flow. So writing programs that do different things based upon certain conditions. Super, 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 super powerful and important. And, you know, if you think about every single program that you run as a user, you know, Google Chrome, like just every single program is full of control flow, like unimaginable control flow. Like just think about, you know, a web browser. You should only visit google.com if you type in google.com into the browser, right? So the whole thing is like a big branching of control flow. Now, this is a bit of a different lecture because it's a pre-recorded one, but you should still scan that lecture code right there. Feedback code, give me some feedback on this content. Did you like it? Remember, pacing is really difficult. There's 1,000 students in the course. Some say to go faster, some say to go slower. So, you know, you're on YouTube, slow it down, speed it up, pause, go back. That's the power of it. It's only a 45-minute video, so you can spend a bit of time doing that. But I will say, I hear from students all the time that they watch lecture videos at 1.5 or sometimes even 2x speed. That I think is too fast, and I'm not a particularly slow lecturer, so try to resist doing that. All right, I hope you enjoyed the public holiday anyway, and you will see Sasha on Tuesday, and then I'll be back the week after. Bye.